Hello. Welcome to this practice set on systems of inequalities. As always, like and subscribe to the channel for more math content. Drop a comment or question below and check out the other playlists on the channel. Without further ado, check out these problems. Pause the video here to work these problems on your own and then come back to check your work. All right, so for this first one, both of these inequalities are in slope-intercept form, which does make them much easier to graph because we can use the slope and the y-intercept to get there. And we can also use our little shortcut with the y being greater than or less than. Now, what I'm going to do is essentially assign a color to each of these. Okay, so that we're working in different colors. So for this first one, I can see that the slope y-intercept is -4. So I'm going to go down here, put a dot there at the -4. And the slope here is 2. You just want to remember that's 2 over 1. So it means I'm going to go up 2 and right 1 from the y-intercept. So up 2, right 1. And because I don't want my lines to drift too much, I'm just going to continue going up 2, right 1. Oops. There we go. And this is just so my line doesn't drift too much. Okay, and I can also go down 2 and left 1, down 2, left 1. That's your point there. Now, before I do the line, I want to make sure that I know what's going on, and you can see that that line does not have the equal to, and so this should be connected with a dotted or dashed line. If you accidentally do a solid line there, you want to grab an eraser and make that clear. Now, this is a less than, and so we have a nice little shortcut for figuring out which side we should be shading, and it's y is less than. So I'm going to come over here and look at my y-axis, and remember that the greater y's are going up and the less y's are going down. So if it says less than, I want to shade the less than side. Now I'm going to use on this the highlighter. Okay, now typically if you were doing this, the gold standard of I'm doing an inequality is probably a colored pencil, because that gives you the ability to control a lot of the shading on it. If you don't have colored pencils, you might do one in pen and one in pencil. You might use 2 different colored pens. If you only have one color, like if you only have a pencil, typically what you can do is just do all of the shading lines in one direction, like so. And I'll kind of show you where you can go with that. Now, let's take a look at the next one. So I'm going to pick green for the next one. This one has a y-intercept of 5. So I'm going to come up here. Here's the 5. And the slope on this one is a -1. Okay, so that's -1x. So that means I'm going to go down 1 and right 1 from my y-intercept. So down 1, right 1. And I'm going to get into that shaded territory. This is where it's good if you've got colored pencils, you can go a little bit lighter so that you can see the points, because sometimes the points will be inside the shaded region. And this one does have an equal to, so this will be a solid line. I'll do my best solid line. And this one is a greater than, so we're going to shade on the greater than side there. And I'm going to pick a matching color. So we're going to do the Y's on the greater. And again, I am using a highlighter there. Okay, and what you want to be able to notice when you were done, if you don't have multiple things to work with, so if you only have like the one color, what you can do is shade the other region just going in the other direction. So what you'll have is like a chunk of the graph that has like the hash, it's going to be hashed out in both directions. Now you do want to make sure that the shaded region is very clear what is shaded. What this program did was it kind of did the highlighting over the highlighting, so I'm not super thrilled with that. I prefer if you can actually see both colors, which you can if you use colored pencils. What I've had students do, if there was some kind of question, they'll do something to write me a little note, this here, and they'll like draw an arrow to the section that they want to to indicate like this is the section where both are shaded. Make sure that you can clearly see both lines and enough points on those lines so that a teacher can tell that your line is in the correct spot. Make sure that you can tell whether the lines are dashed or solid and which direction the shading is in and where the region of overlap is. So it should be darker, it should have like crisscross hash map marks, it should have more than one color, something like that going on. All right, for the next problem, these ones are not in slope-intercept form. So you can decide to do these by building a table, but I am a fan of slope-intercept form. So I'm going to assign the first problem blue. And we're going to go ahead and solve that for y. So I'll start by adding the 3x to both sides. So I have 5y is greater than 3x minus 5. And then we'll divide everything by 5 to get y is greater than 3/5 x minus 1. So my y-intercept on this one is a -1. And the slope is 3/5, so I'm going to go up 3 and right 5. So 1, 2, 3, 1, 2, 3, 4, 5. And I might be able to do that again. Up 1, 2, 3, right 1, 2, 3, 4, 5. And to make sure I don't drift, I'm going to go down 1, 2, 3 and back 1, 2, 3, 4, 5. And I think I can do that one more time. 1, 2, 3, 1, 2, 3, 4, 5. And this is a dashed line. So I'm going to make sure that I'm making it a dashed line, and it is y is greater than, and remember your y values as you go up are greater. And so I'll grab my highlighter and just shade that in. Okay, so there's my blue shaded region. And what kind of color do we want to pick? Let's do this orangey color. Switch my tools over. There we go. And we'll do the same thing with this one. So we have 3x plus 5y is greater than 10. Subtracting 3x from both sides gives us 5y is greater than -3x plus 10. Okay, now you could have 10 minus 3x, but then you might want to switch the direction around. Divide everything by 3 and we'll get y is greater. Divide by 5. Sorry, I'm like looking at a 3. Divide by 5. We'll get -3/5 x plus 2. So my y-intercept in this one is a 2. So I'm going to go put my dot at the 2. And this time I'm going to be going down 3, right 5. So down 1, 2, 3, right 1, 2, 3, 4, 5. Down 1, 2, 3, right 1, 2, 3, 4, 5. And to keep my line straight, we'll go up 1, 2, 3 and back 1, 2, 3, 4, 5. And 1, 2, 3, 1, 2, 3, 4, 5. There we go. This will also be a dashed line. So I'll make sure that that line is dashed. And for our shading, we are going to be looking at greater than again. So we're going to be looking at above the line. And there you go. Okay, and if you think that there's anything remotely unclear about it, you could say here. It's that chunk that's got the blue and the yellow shading in it. And that one you can kind of see where it's crossed. So you can see clearly the 4 regions. So you got a region where nothing is shaded. This is only blue. This is only yellow. And this is both. Make sure that your shading does not stop at arbitrary lines. So your border line is the line that you stop at. I have frequently seen students stop at like the x-axis or the y-axis and they kind of stop their shading. And that can lead to deductions just because it reveals a potential misconception of what the solution set is. So you want to avoid that. All right, last problem. Graph the solution for this situation. So you work as a math tutor and in a local coffee shop. So you're swinging 2 side hustles here. Your tutoring job pays $20 per hour. Now, tutoring actually can pay a lot more than that. But typically, if you are a high school student, you are like also learning math yourself, and so you might get paid for doing it. If you're a college student, you can probably command at the time of this recording like $35 an hour. If you actually have a degree in math or you are like a math teacher, you can easily command like $50 to $60 an hour. So you can get paid more depending on the level, like your own personal level of expertise. But let's just say if you're a high school student and you're just tutoring somebody in your church or something, they pay you $20 an hour. Now, your coffee shop jobs pays $15 per hour, and you can't work more than 10 hours a week. Okay, so you got all your schoolwork to do. Maybe you belong to a club, play on a sports team. You got other stuff going on. So you can't work more than 10 hours a week, but you need to make at least $150 a week to pay whatever your expenses are. Maybe you've got some car insurance that you need to pay, or this is to put gas money into your car to get to your coffee shop job, or just to hang out with friends. You want to go to a theme park or something. Write and graph. Sorry about the typo there. Write and graph a system for this scenario. Now, I did make, if you look at the graph I put together here, I did extend these to -1. Now, you can't work negative hours. Like the smallest number of hours that you can work at a job would be 0 hours. But this just kind of gives us a little bit of I don't know, like wiggle room on the graph so that things are not right like to the edge. So we've got tutoring hours and coffee shop hours, okay? And we can represent these with like maybe C and T for coffee shop hours and tutoring hours. And just keep in mind that we're putting C on the x-axis. So we have coffee shop hours on the x and tutoring on the y-axis up here. So we know that your tutoring hours plus your coffee shop hours have to be less than or equal to 10. All right, so that's our first inequality. So you can work no hours during the week, I guess, in theory, but we can't work more than 10. So we're capping you at 10 hours of work a week. Now, we also know that the money that you make has to be at least $150. So the amount of money you make at your coffee shop job would be 15 times however many hours that is. And you're going to add to that $20 times however many hours you spend tutoring. And you want that money to be greater than or equal to $150. So there's the two systems or the system of inequalities. And now we just need to figure out what is the best way to get this graphed. So I'm going to say like we've got tutoring on the y-axis. So I'm going to solve these for T. So we're going to subtract C from both sides. So this is T is less than or equal to negative C plus 10. Okay, and that of course would be negative 1C. And then this one, what are we doing? We're going to subtract 15C from both sides. You might hear a cat. Sorry about that. She wants to learn some math here. All right, so we have 20T is greater than or equal to negative 15C plus 150, and we'll divide everything by 20. And we'll get T is greater than or equal to negative 3/4 C plus 7.5. It's going to be 7.5. Okay, so let's go ahead and get those graphed and see what we see. So I'll use green for this first one. The y-intercept on this first one is a 10. And the slope is -1. So I would come down 1 and right 1. And so that line goes there like so. Okay, and this is the line that represents how many hours per week. And that has to be less than or equal to 10. And so this is a less than. So we're going to be shading under the line. Okay, so this represents the amount of hours you can work. So just like, and kind of interpret this, you could work 10 hours at tutoring and no hours at the coffee shop. So just so we take a moment and interpret this. This is the point 0, 10, which means you'd be working 10 hours at your tutoring job and no hours at the coffee shop. If you come down here and look at this, this is the point 10, 0, which means that you'd be working all 10 hours at the coffee shop and no hours tutoring. And then you got everything in between. So if you like were to look at this point right here, this is the point 6, 4, which means that you would be working 6 hours at the coffee shop and 4 hours tutoring for your total of 10 hours. So this line right here is giving you that maximum number of hours you can work. Now I am going to take a moment and see if I can make it a little bit straighter here. Okay, and it is a solid line, and notice that we're shading everything underneath it. So in theory, you could also do something like this. If you were to look at this point right here, this is the point 4, 2. So you could be working 4 hours at the coffee shop and 2 hours tutoring, and that would put you in your like limit. So it's less than or equal to 10 hours. Now the other equation or inequality here has a y-intercept of 7.5. So that's right there. And from there, we're going to go down 3 and right 4. So down 1, 2, 3, and right 1, 2, 3, 4. And I'm going to do that again. Down 1, 2, 3, and right 1, 2, 3, 4. And then we're probably going to go off. Okay. And this is also a solid line. And this one represents the amount of money you need to make. And this is a greater than or equal to, so we would be shading above. And so I'm going to, okay, just shading above. It's everything that's above the red line. Okay. And then what I might do just to make it clear is I'm going to turn on my highlighter and I'm just going to like highlight the region of overlap. Okay, so that is the number of or the set of points that represent all the possibilities that you have. So you're going to meet under your time limit, but over, at least over your amount of money that you need to make. So if you were looking at the regions of the coordinate plane here, down here, you can't really see it. It's going off. If we extended it backwards here, you'd have some area that wasn't shaded at all. And that would mean that you'd be over the amount of hours that you needed to work and also under the amount of money. I don't think that's like super feasible here because of where those lines are intersecting, but in theory, there's a section of the white of the grid that's not shaded at all. The ones that are only green are points that represent you're working under your 10 hours, but you're not making enough money. Okay, so if you only work 1 hour at the coffee shop, yeah, that meets the under 10 hours, but you're only making 15 bucks. The points that are in just the red are points where you are making all kinds of money. Okay, you are definitely making your money goal here, but you're working way too many hours to do it. And the sweet spot, okay, this is where you are making enough money. You're hitting your at least your $150 a week, and you're also staying under the 10 hours. And so that is probably a pretty good application problem. You can see what kinds of things are done with the coordinate plane. Looks like my cat has decided to take a perch on her tree, so she is bored with this, I guess. I don't know. I don't know why she'd be bored with it. I think it's cool. Okay, so don't forget to give this video a thumbs up if you found it helpful, subscribe to the channel for more math content, and check out the other videos and playlists. We have everything you ever needed to know about lines and linear equations. So anything with solving a linear equation, graphing a linear equation, all the different forms of lines, inequalities, and systems. If it has something to do with lines, we have a video on it. And if I don't have something, if there's something that is missing off of the lines playlist, drop me a comment and let me know, and we'll make sure that we get that video recorded. All right, thank you very much, and I will see you in the next one.